Hey YouTube, welcome back to my channel. Today we're gonna solve the inserting interval. So we're given an array of non-overlapping intervals where the start value will be the start and will end at the ending value, which represents the start and the end of the ith interval, and the given input is sorted in ascending order by the starting value. So we are also given an interval called the new interval, which is in the same format and represents the start and the end of another new interval. So we need to insert this new interval into the given input such that the given input will still be sorted in ascending order by the starting value, and the given input will still have no overlapping intervals. So we need to merge overlapping intervals if necessary. And we will return the interval after the insertion. So there is notice that we don't need to modify the intervals in place. So we can have additional or extra space to store the output list. So basically we can go through one example. As we introduced in the previous videos, that when we encounter the problem including the intervals, we can draw a number line. Basically, we'll go through the second example. So the starting boundary will be like 0 and the ending boundary will be like 20. All right, so basically these 5 lines are the initial input, right? And our new interval is from 4 to 8, this red line. Before we start our analysis, I want to mention 2 edge cases. So first is considering the boundaries. So if we have a interval start from 0 and end at 0, basically, which is a single value. So the ending value of this new interval is smaller than all the starting value in the given input. So in this way, we will just insert this new interval at the very beginning of the output and then extend the output list with the given input. So basically, there were fewer operations in this case. And then for another boundary, if the starting value of the new interval will be a very large value, will be 100, which is larger than all the ending values in the given input. So we will know that we can append all the intervals from the given input into the output, and then at the very end, we will just append the new interval into the output list and return. So for these 2 boundary cases, that'll be very easy operation for us to do, but we need to keep in mind that to deal with these 2 boundaries. And another edge case is that for 2 intervals like 1, 2, and 2, 3, this is also an overlap interval. So these 2 intervals will be regarded as having overlap if they share the same ending value and the starting value. So we will merge this to 1, 3. So these are 2 edge cases we need to keep in mind when we analyze the second example. So, okay, there is a very helpful information that this interval has been sorted in ascending order. So we can basically go through every interval in the given input in a great sequence. So basically, first, we will have the 1, 2, and we will check the starting value of the new interval and the ending value of the current interval. So 4 is greater than 2, which means there is no overlap. One thing to mention is that if we want to create a function to check if there is an overlap, we may not do that in this question. Because in this question, we really want to determine if a new interval has no overlap with the current interval, whether it's behind or before the current interval. So if we just have a function to check whether they have overlap, we will need more decision-making conditions to check the before and the behind stuff. Okay, so we know that the starting value is greater than the ending value, and we will keep moving to the second interval in the given input. So we found that the starting value of the new interval is smaller than the ending value of the current interval. So we know that there is overlap, right? So we will merge these two intervals. We will show how we're going to do this in code. So basically, we'll just compare their starting value, which is minimum, and their ending value, which is maximum, and keep the minimum and the maximum as the merged value. So it will be like this. Basically, it's from 3 to 8, and we can cross out this interval. And then we will go to the next interval, which is 6 to 7. So as we mentioned before, we will first check the starting value of the new interval and the ending value of the current interval. So, because it's sorted in ascending order, so if the starting value of the new interval is smaller than the ending value of the current interval, we will determine that there is an overlap. So the same thing as the last step, we will merge these two intervals, and we will compare their starting value and their ending value to pick up the minimum value as the start value and the maximum value as the ending value. So basically 6 to 7 is the subset of 3 to 8. So we will just cross out this interval and keep this merged interval. And then when we come to next interval, we will have the 8 to 10. And in this case, as we mentioned in this edge case, if two intervals share the same value on the ending value and the starting value, we will reckon that they are overlapped. So we will merge them using the same algorithm, and we will extend this to like this red line here, and it will be 3 to 10, and cross out this interval. Then, because the ending value, the new interval is smaller than the starting value of next interval, so we determine that there is no overlap between these two intervals. So basically, we end our iteration, and we will return these 3, 1, 2, 3 intervals as the output. Basically, we have 1 to 2, 3 to 10, and 12 to 16. So that's basically what's the output look like. All right, so I'll show you how to implement this in code. All right, so let's get into the code. So first, as we mentioned in the drawing, we will have a result list as an extra space to store our output. And then we'll basically go through every intervals in the given input intervals. Okay, so first, we basically want to check if the new interval is literally before or behind the current interval. How are we going to do this? So first, we will write some condition to decide whether this interval is before the current interval. Because in this case, our operation will be very easy because our new interval will have no overlap with the current interval. We can just append the new interval into the result list and extend this list with all the rest intervals, right? So if the ending value of the new interval is smaller than the start value of the current interval, we will know that the new interval is before the current one. So what we will do is to append the new interval into the result list and return the result plus interval from I to end. So basically we can do that concat in Python. Then we want to decide whether the new interval is behind the current interval. So in this case, the starting value of the new interval will be greater than the ending value of the current interval. So why we use smaller and greater here is because if two intervals share the same value at the ending value and the starting value, we will determine that there is some overlap between them, right? So that's why we use just greater and smaller sign here. So in this case, we will append the current interval into the result. And we can't decide whether the new interval has overlap with the next interval. So we will not append the new interval into the result at this step. So the else case will be overlap. So what we're gonna do is to merge two intervals. How we're gonna do this is to find the minimum value from the starting value of the new interval and the starting value of the current interval. And the ending value will be the maximum value of the ending value of the new interval and the current interval. And we will update new interval with this merged interval. Then basically we are done. But we need to mention is that if there is edge case that the starting value is greater than all the ending values in the given input, basically like, so say we have a new interval, the starting value is 100, which is larger than all the intervals in the given input. And then if we want to append the new interval into the result list, the new interval should be like inserted before at least one value in the given input, right? If the case is what we mentioned, like the starting value is 100, we can never do that in this for loop. So what we are gonna do is to, like, if there is no return in the for loop, we will append the new interval into the result list and then return the result list. Because except for this edge case, we will always have a return in this for loop. All right, so let's see the result. Oh, so one typo here. It should not be the interval, it should be the intervals. All right, let's see the result again. All right, so we solved this problem. I hope to see you soon in next video.